Hello everyone, I am Dr. Abha Kumari. Today we will discuss some new chapter of integral calculus, that is area of plane curves. So in this chapter we will see that how can we find the area of some plane, closed curves or the portion of the plane curve bounded by the lines. So here we see the area of a curve given by Cartesian equation. So number one is area of a curve given by Cartesian equation. So what is Cartesian equation? So refer to the rectangular axis of coordinates, the area included between the curve, the axis of x and the two ordinate x equals to a and x equals to b is represented by the definite integral, and the area is given as integration from a to b y dx. So let us prove this theorem. So what this statement here is, refer to the rectangular axis of coordinates the area included between the curves the axis of x, fine, and two ordinates x equals to a and x equals to b is represented by a to b y dx. Fine. So let us prove this equation or this formula. Now to solve the theorem, to find the area in Cartesian coordinate, let us first draw a figure. Okay, so not proof. Let O be the origin, OX be the initial x-axis, OY be the y-axis. Right. Let CD be a curve. So from this, let a point P be this on the curve and the coordinate are x and y. Let here be the point R, okay, Q. It will be Q. So Q, and the coordinates of the Q is x plus del x and y plus del y. Fine. Let the curve be C and then D. Now we draw a perpendicular from this point P, that is PM, and from this point Q, QM. Okay. So here is a small increment by a del x. So let us join this point. So we have draw a parallel point from this. Then we join this point P. From P again we draw a perpendicular to the line Q and let it be I. So here is T. So this is the extended area of the curve. So what we have to find here is, let CD be a curve whose equation is y equal to fx. Okay, and CA and DB. CA. So what is CA? So from C we will draw a point line perpendicular. From this point C we draw a perpendicular, this is CA, and again from D we draw a perpendicular, that is DB. So AC and DB, okay, are two ordinates at x equals to a and x equals to b. Therefore, this length is your a and this length 0 to b is your small b. Right. So here we have to find the area of A, B, C and D of this complete portion. So to find this area, let the coordinates of P be xy, and to find the area of AB, CD, let the coordinates of PB, xy and QB, x plus del x and y plus del y. Right. So that from figure, what we have from figure is, here in this figure we have OM equal to x because we have a point P is xy. So this length is your x. So x. Now what about ON? This point is your x plus del x, y plus del y. This is your y. So here is the length x plus del x up to n. So ON is your x plus del x. Fine. And MP equals to y and MQ equals to y plus del y. Fine. So let the area AMPC, this small area is denoted by capital A. Let this area be denoted by capital A. Then, because of a small increment, del A in A. अब इस एरिया में हम क्या कर रहे हैं, जब लेंथ हमारा P से Q की तरफ भाग रहा है तो हमारा यहाँ पे x प्लस डेल एक्स इंक्रीमेंट हो रहा है, y प्लस डेल वाई इंक्रीमेंट हो रहा है, इसलिए जो ये एरिया है ये इंक्रीमेंट होके, क्योंकि इसको हमने a लिया है तो इंक्रीमेंट पोर्शन के लिए हम ले रहे हैं इसको डेल a. सो इंक्रीमेंट ऑफ डेल a इन a corresponding to the change del x in x is the area PMNQP. PMNP, this one Q and then P, this one. This area. So we have P, M, N, Q and then P, which lies between P, M, N, Q, T, P and P, M, N, R. There is P, M, N, Q. So P, M, N, Q, T, P, this whole area, and P, M, N, R, this area. So इस पूरे एरिया से अगर हम इस एरिया को हटा दें तो हमें क्या मिलेगा, ये एरिया हमारा लाइज करता है इन दोनों एरिया के बीच में. तो यहाँ हम देख रहे हैं कि ये हमारा एरिया मिल गया, दैट इज del A lies between y plus del y into del x and y into del x. So area of a rectangle A L into B That's why we have an area of this one. First one is whole this area, so we have this small increment is del x. So we have here is y plus del y into del x. Why? Because this whole length is y plus del y, and here this small increment is del x. So this is a rectangle, and that's why we have the area of this MTQN is y plus del y, this one length, and then into del x. That's why we have written y plus del y into del x. Similarly, we have the area for PMNR is y into del x. Right. Or y plus del y into del x is greater than del a, and this one is greater than y into del x. This implies y plus del y is greater than del a divided by del x, and this one is greater than y because del x and del is common, and from both we have taken it in the denominator of the del a. Therefore, by taking the limit, what we have here is limit del x tends to 0, del a divided by del x is equals to limit. So this is equals to what? Here is the limit, so this we can write dA divided by dx, and our area of the curve is y, so y equal to fx. Right. Therefore, dA equals to fx into dx. Right. And this implies this is what? This is y into dx. Therefore, integrating both sides, we get dA. So here is dA equal to y dx, and after integration we get a function of fx plus c. Now here is the initial integration constant, so here we have to find the value of c. So to find the value of c, where c is constant and fx is an indefinite integral of fx. Right. Now, when x equals to a, what about a? A is 0. Okay, here in this figure, when x equals to a, what about y? Area? No. So this one is 0. So here we have when x equals to a equals to 0. Also, when x equals to b, the area A becomes required area A1. Let it be A1. Therefore, by putting this value in the equation number 1, we have here in the equation number 1, this one. So what we get here is 0 equal to FA plus C, and A1 equals to F of B plus C. Therefore, by putting this value, what we have here is A1 equals to FB minus FA. Okay, by subtracting this value, CC is being cancelled. So we are looking for the value of A1. So here A1 is so here we are looking for the value of A1, and A1 is FB minus FA. And what this A1 is? FB minus FA. FB minus FA is your A to B fx dx. From the definition of integration, we can write FB minus FA as A to B fx dx. Right. Therefore, the definite A to B fx dx represents the area bounded by the curve y equals to fx, the x-axis, and two fixed ordinates x equals to a and x equals to b. Thank you.